All right, page 213 in your textbooks. Hope you did well on your quiz yesterday. If you didn't, you can make up for it on your exam, right? You got an exam coming up tomorrow. We will have another review tomorrow before the exam. So got a review today, review tomorrow, exam tomorrow. Though really, truly, the beautiful thing about math is you've been reviewing all year long, right? Homework constantly reviews. So there really isn't anything, speed drills review. There really isn't anything that it's been forever since we've looked at it. But there are some things today and tomorrow we want to go over that's maybe been a little while since we've looked at them in earnest. Let's start though by going over your homework from last night because as I said yesterday, over 40% of the points on the test are going to come from Chapter 5. Area, surface area, lateral area, different shapes, that kind of stuff. Knowing your formulas. That's a big part of the points on the test. So let's take a look. Number 1 on the homework. If the radius of a circle is 30 centimeters, what is its diameter? Griffin?
60 centimeters.
60 centimeters is correct. How would I find the area of a circle, class?
A equals pi r squared.
A equals pi r squared. We're on page 213. There we go. How would I find the circumference of a circle, class?
C equals 2 pi r.
C equals 2 pi r or C equals?
Pi d.
Either one of those. Number 2, what is the name for a three-dimensional figure with 2 circular bases with equal radii? What you got there, Corey? Cylinder. Number 3, what's the name of a three-dimensional figure with 6 equal faces? Elaine? Cube. Number 4, what is the name for a face that is on the top or bottom of a three-dimensional figure? Ben?
Pyramid.
A face. What do we call a face that's at the top or bottom of a figure? Usually think of the bottom. The face on the bottom.
Bottom?
No. The base. The base of the figure. Number 5, what shape do we have back to Ben?
Parallelogram.
Parallelogram. What's the formula for the area of a parallelogram?
A equals
Michael? BH. A equals BH. So what we had to do on number 5 was just multiply those two values. 41 times the 28. Michael, what'd you get for your area?
A equals 1,148 meters squared.
1,148 meters squared is correct. Number 6, obviously we have what shape, class?
Circle.
Circle on number 6. And tells us the radius is 24 feet. Again, how do we find the area of a circle, Luciana?
Pi r squared.
A equals pi r squared. So we first have to do what?
Square the radius.
Square the 24. 24 times 24, get your 576. Then we got to multiply the 576 by pi, or 3.14. Now again, it's not exactly 3.14. It's approximately. So what's your answer for number 6, Luciana?
Approximately 1,808.64 feet squared.
There we go. Approximately 1,808.64 feet squared, correct. Number 7, they want about the surface area and lateral surface area of that figure. What do we call that thing in number 7, Bryson? A rectangular prism. And for the surface area, again, we're just going to multiply the dimensions together. So let's start with the easy 2. 3 times 1, class?
3.
Double it? 6. Then let's take the next easiest one. 1 times 9. Double it.
18.
And let's take the only one we ain't used yet. 9 times 3. Double that. 54. And then when we add all of them together, what do we get for that surface area, Bryson? 78 inches squared. For the lateral area, we just have to knock out one of these numbers. Which number do we knock off for our lateral area here? Jalen? 18. The 18, the length, width. And do we all see on number 7, the length is the 9, the width is the 1. Those are the dimensions of the bottom. Knock out the 18, so our lateral area is 60 inches squared. Number 8, we have a cylinder and formula for the surface area of the cylinder. Elaine?
I'm scared. Okay. Pi equals.
Not pi equals, SA equals.
I didn't know. Okay.
Remember, we got a circle on the top and a circle on the bottom.
So pi, and then there's RH somewhere.
Okay.
Oh.
What's the area of a circle?
Pi r squared?
Okay, and we got a circle on the top and a circle on the bottom. So what's that?
I don't know, but I think I just.
How about 2 pi r squared?
Yeah.
2 circles. two circles.
I was thinking about
Ne-
the next one.
And then add on what else to that?
2 pi RH.
There we go. Okay, so remember we got two circles, plus we have the 2 pi RH. For the lateral area, that's just,
2 pi r squared. I didn't mean that. 2 pi RH.
right, because remember the height of the cylinder is part of that wraparound. So we have the base, which is a circumference, times the height. But yes, as far as the top and bottom, remember it's a 2 pi r squared. So we've got a radius of 5, and so let's start by squaring that radius, Elaine.
25.
Double that,
50.
and multiply 50 times 3.14. I'm going to knock off a decimal and a 0, and multiply there, we get, what is that, 157.0? And then approximately. And then over here, we got to multiply the radius times the height.
Which would be 100.
100. 5 times 20 is 100. By the way, 3.14 times 100, all we do is knock off the
0.
2 decimal places, right? So that's 314 times 2 gives us,
314. Right?
well, times 2.
Oh. 6.28.
Well, it would have been 6.28.
628.
There we go. We knocked out the point, so it's a full 628. So when we got 157 and 628, what do we get for our surface area?
785.
Approximately 785 meters squared, but we've already done the lateral area. We don't need to redo it, Corey. We already have it on the chalkboard.
628 meters squared.
Approximately 628 meters squared is correct. How many got those answers on 1 through 8? Anyone perfect on the homework? Anyone just miss one answer? Anyone just miss 2 or 3 answers? Are there questions on anything? Yes, ma'am.
So somehow, on number 8, on surface area, the 25, I didn't square it, but I still got 157.
Well, I mean, at some point you must have squared to get to 25.
No, not square. I'll double it. The 25. I didn't double the 25.
Oh, well, if you did 6.28 times 25, that gives you the same 157.
Oh.
Yeah, I just figured it would be easier to multiply a 50, so I went ahead and doubled the 25 to make it a 50, so I'd have a 0 to knock off with a decimal. But you don't have to do it that way.
I didn't realize that I doubled it.
No, that's okay.
before
Can you
I
hand
answered
me?
the question.
All right, questions on the 1 through 8? Yes, sir. Oh, yeah, go ahead. Any questions 1 through 8? Flip back then, if you would, or look across the page, excuse me, page 212. And Sam is just in time. He's back with us, feeling better. He didn't have a chance to do this last night because he was still, trying to get better. But we're on page 212, Sam. We've evoked your name here. You're wrapping a Christmas present for your mother. And so if you would, at the bottom of page 212, read problem 18 for us.
Sam wraps present for his mom for Christmas. The present is the shape of a cube. On the edge of the cube is 5 feet. What is the total area that needs to be wrapped?
That's a big present. I mean, 5 foot all the way around. This is a great big box. I don't know what he's got in that box. I mean, you could fit like a washing machine, a dryer. You could fit way more than just a Corey in there. Besides, she doesn't want Corey. But Corey's mom wants Corey. Sam's mom doesn't want Corey. Anyway, but I digress. I don't know what we've got in the box. Maybe it's a new oven. I mean, that's about. I had to get a new range right around Christmas time several years ago when I busted the old one. And so maybe that's what he got, Mom. Anyway, we're trying to find how much area needs to be wrapped. In other words, Sam, it doesn't use these words, but what are we finding?
Total area that needs to be wrapped.
Yeah, total area that needs to be wrapped. What do we call that? What's the term for it? Just put the water bottle next to your seat. We don't call it area, Griffin. Surface area. We call it surface area. And if it is in the shape of a cube, we're going to use the formula, and always write the formula, class. Get yourself some free points just in case. What is the formula for the surface area of a cube, Sam?
6e squared.
So we're going to start by doing what?
Replacing the e with 5, multiplying by 5.
All right, square the 5. Square the 5 foot edge to get
25.
25 feet, and then or feet squared, and then multiply that by the 6. And what would we get for our answer, Griffin?
150 feet squared.
150 feet squared is correct. Number 19. Go and read that for us if you would, Ben.
Jake is
Mowing.
Jake is mowing the lawn for his grandmother. Her yard is the shape of a square. If the length of one side of her yard is 12 yards. What's the total area of yard that Jake needs to mow?
All right, what shape are we dealing with, class?
A square.
A square. So when it says what's the total area of the yard, we're really just finding, Ben, the
inside of the square.
area of a square, right? The inside of a square. What's the formula for the area of a square, Ben?
A equals S squared.
A equals S squared. Did we realize, class, that they were not asking for surface area? The yard is not a solid shape, so if you went with a 4e squared or a 6e squared, you fell into their evil trap. How many realized we just needed A equals S squared? How many fell into the trap? Really? None of you? Wow, awesome. And so all you got to do is square the S, square the side, square the 12 yards. Ben, what's our answer?
144. Yards squared.
144 yards squared is correct. Number 21. Let's see. Elaine, your mom helps out in the library from time to time. She's not the full-time librarian, but go ahead and read about the librarian for us.
The local librarian was repainting 6 columns in the library's lobby. The columns are rectangular prisms. If the height of each column is 8 feet and the base is 2 feet by 2 feet, what is the total area that needs to be painted?
Yeah, the school that I went to had these large columns that supported different areas. So our library actually had columns holding things up, and they were about this big, so you couldn't miss them. And they were usually brightly colored, so you wouldn't miss the fact you'd run into them. And so anyway, large library, and it says 6 columns. Tuck that thought in the back of your mind. All right, so the height of the columns, 8 feet. That's a usual ceiling height, so that's pretty realistic. 2 feet by 2 feet all the way around. But is the librarian going to paint the top of the column, class? No, because it's up against the ceiling. Is she going to paint the bottom, class? So we're really finding what here, class? Lateral area. And so what's the formula that we need to use here, Elaine?
It's, what's funny? I messed up. It's, BH plus, wait.
Well, lateral area of a rectangular prism.
You cut out the LW.
We cut out the LW part, yep.
Oh, WH and then BH.
Well, not BH. We don't call it the base. We call it, class, the length. So
LH.
LH. But there's 2 length heights and there's 2 width heights, right? So our formula is going to be 2WH plus 2LH, right? Because there's all 4 sides that she's going to be painting. So we just grab a couple numbers. Well, we've got 2 foot width by 8 foot height, 2 by 8.
Yeah, I'm going to have to redo this. Okay,
That's right, 2 by 8.
16.
Double that.
32.
But the length is also 2 and the height is 8, so 2 by 8 is again
16.
times 2.
32.
32 again, and we add those together, we get
64. Maybe? Did I do the wrong math in my head?
no, you're correct. 64
Square, whatever that is, feet.
square feet, or feet squared. That's 1 column. But, class, it said that there are 6 columns. So we then need to take the lateral area of 1 column, multiply that by 6, and what would we get for our final answer, Kirsten?
414.
Ooh, not 414, you got it?
384.
384 square feet is correct. 384 square feet. How many had that final answer on 21? How many left it at 64? Forgot about the 6 columns thing. You just found 1 column. How many found surface area instead of lateral area? Okay, questions? Questions. All right. Flip over, if you would, please, to page 210. Flip back just another page or 2. For sake of time, we're not going to actually work these because we've got quite a bit of review to get through, but I want to make sure we take time to talk about them. On the bottom of page 210, it says to find the area, not surface area, just area of each figure. What's the formula I would use on number 1? Michael?
A equals 1/2 BH.
Good, A equals a half BH. Now, Michael, on number 1, there isn't a good number to cut in half. So he said, if that's the case, what should we do?
Multiply by 0.5.
Good. Just go ahead and multiply base times height. In this case, that would give us 63. Then multiply that by 0.5. Number 2, what formula should we use, Luciana?
A equals 1/2 height times quantity of B1 plus B2.
Good. 1/2 H times the quantity, B1 plus B2, which means the first thing we'd have to do, Luciana,
Add B1 and B2.
Then add the 2 bases, it'd give you 22. Now, conveniently, you could either take half of the height of 4 or the half of the bases, which is 22. Either one of those, and then multiply. to get your answer. Number 3, what formula would we have to use to find the area of that circle, Bryson?
You have to do
A equals pi r squared, but they didn't give us the radius, Bryson. They gave us a diameter. So what do I got to do? So what is the radius on number 3? 9. And then to plug it into the formula pi r squared means we'd have to do what first? You're following along, paying attention, Jalen.
You'll have to double the pi r squared.
Not double a pi r squared. You were correct about the formula for the area of a single circle is just pi r squared. We said the radius is 9 inches.
You're supposed to do 9 times 9.
Good, square it, right? 9 times 9 first, that would give us 81. And then we multiply the 81 by 3.14, whatever that is. For number 4, we have a little scale drawing here, but what is the shape that is pictured for us, Jalen?
A rectangle.
And what's the formula for the area of the rectangle?
Area equals LW.
A equals LW, length times width. Now, really though, Jalen, on number 4, what's the actual length? 12 feet, and the height is, or width rather, is really 6 feet. So we can do that in our head. We can actually get that answer, 12 times 6. 72 feet squared. Look at number 5. What's the formula we would have to use for this, Sam?
A equals S squared.
S squared, which means what would we have to do to solve number 5?
8.5 times 8.5.
Good, not times 4. That's perimeter. 8.5 times 8.5, whatever that is. Number 6. What formula do we have to use, Ben?
Number 6.
Stay with me.
A equals, is it area or is it perimeter?
Area.
A equals 1/2 BH.
A half BH. Good. And there is a number that's easy to cut in half here, Ben. Let's cut the
16.
in half to get,
8.
and then we multiply the 8 by the
15.
15. It ends up being 120 centimeters squared. Number 7. What formula do we have to use? Kirsten.
A equals 1/2 H times the quantity of B1 plus B2.
She gets all choked up just hearing about it. So we would start by doing what here, Kirsten?
Adding the bases.
Add the 2 bases to get, in this case,
12.
12. We could cut that in half if we wanted.
6.
6 times the 4 gives
Oh, wait, what? Times the 4.
6 times 4, because the height was 4 yards. Anyone?
24.
24 square yards. Or again, you could cut the 4 in half and get 2 and multiply that by the sum of the bases, which was 12. All right, flip the page over then. And number 11, again, for sake of time, we're not going to actually do it, but on number 11, what would be the formula we would use to find surface area of the rectangular prism? Griffin.
Lateral.
Let's start with regular surface area.
SA equals 2LW plus 2WH plus 2LH.
There we go. So we're going to pair them up, multiply, and double. Don't forget to double, and that would give us our surface area. But for just the lateral surface area, what would be the formula we would use here, Corey?
LA equals 2LH plus 2WH.
Very good. So we wouldn't use the 8 times 13 doubled. We'd use the other ones instead. Number 12, what formula would we use for surface area, Elaine?
SA equals 60 squared.
So we'd have to start by squaring the
18.
that'd give you 324. Then we multiply that by 6. But for the lateral surface area, Jalen.
The lateral surface area of number 12, right?
Yeah, stay with me. Pay attention.
The lateral surface area is LA equals 4E squared.
4e squared. So we take the same 18 squared or 324. We'd have found and multiply that by 4. Number 13. If we want the surface area, Bryson, what's the formula we would have to use? It's the long one.
SA equals 2L.
No, not that long one. That's for rectangles, lengths, widths, heights.
Yeah.
Cylinders have radii and heights. Ooh, make sure we memorize it by tomorrow. Luciano, what's the formula for surface area of a cylinder?
SA equals 2 pi r squared plus 2 pi r.
Good. What is it, Bryson?
2 pi r squared plus, or 2 pi r squared plus 2 pi. No, I don't know why.
2 pi r squared plus 2 pi r h. All right. The lateral surface area, by the way, would only be what part of that formula?
2 pi r h.
The 2 pi r h. Now, class, for the 2 pi r h. Thoughts on number 13? Look at that h.
Oh,
I could use what class?
22
22 sevens. Unfortunately, I can't use it on the 2 pi r squared though, can I?
No.
Because when I square the r class, I would get, oh, careful, 16. 4 squared is not 8, it's 16. And so that doesn't have a 7 in it. So I could only use the 22 sevenths on half of it. Maybe it's easier just to go ahead and stick with the 3.14, but I love first shortcuts anywhere I can find them. Flip over now to page 243. Page 243. Let's get back to reviewing some old stuff. Some stuff that it's been a little while. For instance, it's been a little while since we've done greatest common factor and least common multiple. But for either of these, class, the key is to start by doing what to our numbers? Prime factoring them. So let's look at 48. Let's look at 64. Let's factor the 48. How might we split that up, Michael?
By 24.
I mean, you could do 24 and 2. I was thinking 6 and 8, or maybe 4 times 12. You know, something we memorized in school. How might we split up the 24, Michael? 12 and 2. How might we split up the 12? 6 and 2. How might we split up the 6? 2 and 3. There we go. So our prime factors then are a whole bunch of 2's and a lonely little 3. For 64, if we were to factor that, Kirsten, how might we split that up?
12.
Well, 12 times 5 would be 60. There's not a 12 in 64, but it is a number we memorized on one of our multiplication tables as kids, Griffin.
8 and 8.
8 times 8, yeah. Where 8 times 8, let's go back to Kirsten, could split into,
4 times 2.
and that's both of them. And then the 4's could each split into,
2 and 2.
all right, so our prime factors are literally just a whole bunch of 2's. Greatest common factor, class, you're looking for what they share. You might want to write that right there in your notes as you're doing this with me, not just watching me do it, but doing it with me. Greatest common factor, write that in there. It's what they share. Well, they obviously share a bunch of 2's. How many 2's do they both share, anyone? 4. Now this one's got 6 of them. This one's got 4, but they both at least have 4. They both share 4 2's. So the greatest common factor would be 2 times 2 times 2 times 2.
What?
16?
16 is the greatest common factor when you multiply 4 2's all together. For least common multiple, though, class, you're not interested in what they share. You're looking for winners. You're looking for winners. So write that down next to where it says least common multiple. Well, who wins the 2's, class? The 64. These are all loser 2's, okay? So these 6 2's are winners. Well, obviously, class, if I multiply all those 2's together, I'm going to get 64. That's where they all came from, right? But I also have one winner over here with the 48, class. The 3 is also a winner. And that 3 gets multiplied by all those 2's, or by that 64. And so our least common multiple would be
192.
192. Good, Griffin. 192, our least common multiple. Look at the next set. Doing this with me. 14, 35, 105. The only good way to split a 14 is going to be what here, Ben?
7 and 2.
The only good way to split a 35 is going to be what, Sam? And then 105. I mean, what number should we all see is clearly in 105, class?
5.
Clearly a 5. 5 times what? 21. 2, 1, right? And then 21 can split again, class, into 7 and 3. So when we look for the GCF, we're looking for what they share. What do they all have? They all have a 7. Do they all have anything else? No, this has a 5, but they don't all have 5s, right? So the only greatest common factor then is just 7. But for the least common multiple, class, we're looking for winners. Well, what about ties? Just pick a winner. So, Bryson, which of the 3 7's do you want to be considered a winner?
Let's go
First, second, or third?
first.
These, then, are losers. All right, there's 2 5's. Which 5 do you want to consider a winner, Bryson?
Second.
Second one, loser. All right, so we're just going to take the winners. 7 times 2 times 5 times 3. Let's start, class, with 2 times 5, 10 times 3,
38.
and then multiply the 30 times the 7.
210.
210, and there's our LCM. We remember doing this now that we've gone over it again. Been a little while since we've done it. How about at your seats? Do 54 and 72. At your seats, do 54 and 72. Prime factor them and find your GCF and your LCM. We're at the top of page 243. Clearly the advantage goes to people who remember their multiplication tables really well, right? Because if you're struggling, it's like, well, did we know 6 times 9 is 54? And 9, of course, 3 times 3, 6, 3 times 2, I think we all got that. 12, you could have got 8, 9, 6, and 12. I went 6 and 12, 2 and 3, 3 and 4. 4 splits again into 2 and 2. Class, what do they all share?
3 and 2.
They all at least have 2 3s, right? This has 2, that has 3. So they all have 2 3s, and they all have at least a single 2. So what's the GCF, class?
18.
18. How many found 18 to be your GCF? Questions on that? Going to be able to do that tomorrow?
Yes, sir.
All right, not in our next lesson. We do have a review between now and then, but in our test tomorrow, we're going to be able to find GCF. LCM, class, we're looking for,
Winner.
and this time there is a clear winner of the 2s. The 72 has way more 2s, so this single 2 is a loser. And the 54 is a clear winner of the 3s. These 2 3s lose out to the 3 3s. So my LCM is 333 times 222. Well, what is 333, class?
27.
27. And what's 222?
8.
8. And if we multiply 27 times 8, we get our LCM.
175.
Right?
176.
Oh,
Oh,
wait.
160.
20.
Multiply it out.
260.
216. There we go. 216 is our LCM. Whew, careful on our math there. Fractions. It's been a little while. I want you to do numbers 11, 13, 14, 18. We have seen these on a couple of speed drills in the past couple of weeks, but let's review over 11, 13, 14, and 18 as well. Remember in 11 and 13, when you add or subtract fractions, class, you have to have a common denominator. When you multiply fractions, you cannot multiply mixed numbers. You have to make them improper fractions. And number 18, we don't ever divide fractions, class. We multiply by the
Reciprocal.
But listen, we don't flip unless there's a division symbol, right? Last speed drill, I had some people flip in multiplication problems. Division problems where you flip it, not multiplication. Do those for at your seats. 11, 13, 14, 18. All right, for sake of time, pencils down. Even if you're not finished with all 4 of them, pencils down, look this way. Did we get the common denominator 42? Do we get 30, 40 seconds here? To add to the 142nd, you get 31 40-seconds. And then, of course, 8 plus 9 is 17. Questions on that first one, number 11. Number 13, we should have got a common denominator of 35. Multiply by 7s to get 21 35ths. Multiply by 5 to get 25 35ths. Can you take 25 35ths from 21 35ths, class?
No.
Are you allowed to just go the other way and say, 4 35ths, we good?
No.
No. You got to borrow from the 7. Make it up. And the one you borrow becomes 35 35ths. In addition to the 21 35ths already up here, gives us 56 35ths. Now we can subtract. We get 31 35ths over here. It's 26 minus 5 now is 21. And how many had that answer for the second one? Number 13. Number 14, we got to change them to improper fractions, right? Multiply and add to get 35 ninths, multiply and add to get 9 fifths. Well, 35 and 5 cancel, give 7 and 1. 9 and 9 both cancel just to get 1s. I just get 7. How many get 7 for number 14? Number 18 starts out much the same way. Multiply and add gets 12 sevenths. But do we ever divide, class?
No.
That's where we're going to multiply by the
Reciprocal.
flip it, make it an 11 6. Do a little canceling, not much. Get 2 and 1 to get 22 sevenths. Am I allowed to leave the improper fraction?
No.
No. Make it a mix number 3 and 1 7's our answer. How many got that? Those who made it to number 18. Questions on fractions. Drop down to number 21 if you would, please. Number 21, order of operations. It's been a little while. And we had a little abbreviation, PEMDAS, right? And parentheses, exponents, multiplication, division, addition, subtraction. And so on number 21, the first thing we should do, class, is
Exponent.
exponent. There are no parentheses that we have to do anything inside of. So we're going to start with the exponent. 2 cubed, anyone?
9.
Oh, 8. And it says plus 6 divided by 2 times 3. Then we have multiplication, division. And do we see we've got division and multiplication? Which order do we go, class?
Left to right.
Divide first, then multiply. We're going to go, no, that's always divide first, just left to right, thank you. In this case, divide, then multiply. So we go left to right this way. Divide first here,
3.
then multiply the 3, class.
9.
9. So let's say plus 9 is 17. Look at the next one, number 22. This time I do have to simplify within my, but within the parentheses, I got 2 different things. Which of the 2 things should I do first?
Multiply.
Multiply first. 3 times 5?
15.
Then subtract the 8 to get
7.
7. So it's really 14 divided by 7, class. Well, that's just 2.
2.
Look at the next one. First, I got to start with my parentheses. 3 plus 2 is 5. Then we got to take care of the exponent. So square the 5.
25.
25. Square it before you multiply the 3. Right? So we're going to square first to get 25. Then notice it's multiplication and division. Which one comes first?
Left to right.
Left to right. In this case, it's multiplication comes first. 3 times 25?
75.
75. Then divide the 5 class to get
14.
15. 70 divided by 5 is 14. Let's see, number 29. No parentheses. Or number 24, excuse me. I'm seeing a 9 in the first number. 24. No parentheses. No exponents. So I get to jump to what step?
Multiplication.
Multiply, divide. Do the multiplication real quick.
36.
36. Do the division real quick. 1. Don't lose your plus and your minus, and of course the 2 at the end. And now we just go left to right. 36 plus 1 minus 2. 35 is our answer to the page. Number 25, read that for us if you would, Corey.
If there are 8 slices of pizza and 6 people, what is the ratio of pizza slices to people?
All right, well, what is the ratio of pizza slices to people here? Obviously, class? 8 to 6. But we always do what with our ratios? Reduce them. So, Jalen, our correct answer should be
4 to 2. No, 4 to 3.
4 to 3. There we go. We could write it as 4 to 3. We could write it as 4 to 3, or we could write it as 4 to 3. What do we call the first term in the ratio, class? Antecedent. What's the second term called? Consequent. Good. Number 26. 2 bathrooms, 4 bedrooms in a house. What's the ratio of bedrooms to bathrooms? Elaine?
2 to 1.
Good. Do you see? They tried to be sneaky, and they switched the order. 2 bathrooms, 4 bedrooms. But what's the ratio of bedrooms to bathrooms? 4 to 2. But you said you would reduce this to what again?
2 to 1.
2 to 1. Can we just say 2, class?
No.
No, because then we don't have a ratio anymore. We need to leave it as 2 to 1. Number 27, Deli sold 65 turkey sandwiches on Monday, 70 on Tuesday. What's the ratio of turkey sandwiches sold on Tuesday to total sandwiches? What do we have to do first, class?
Total.
Figure out what the total is. What is the total, anybody? 105. So what's the unreduced ratio of Tuesday sandwiches to total?
40 to 105.
40 to 105. But then let's divide a 5 out of top and bottom. Anybody?
2,
21.
8 to 21. 8 to 21, our answer. Car gets 124 miles for every 4 gallons of gas. What's the ratio of miles to gallons? The ratio of miles to gallons. Anybody?
124 to
124 to 4, but we can reduce it to get, what did you say?
34 to 2.
Not 34 to 2.
32 to 4.
31.
I mean 32 to 1.
31 to 1. There we go. 31 to 1, Bryson and Elaine. Questions on ratios. It's been a little while since we've seen those. Questions? Remember doing that? Let's see. Let's take a look now at 29 to 34. Take a moment to change those to decimals and percents. Back and forth. Decimal to percent, percent to decimal. D2P. 29 to 34. Number 29, when I boink, boink 2 times, what do I get for my decimal, Griffin?
0.06.
0.06. How about 387%? Boink, boink, Kirsten.
3.87.
3.87. Now the tricky one is number 31. 2/5%. You can't boink, boink because there's not even a decimal yet. Class, who remembers what is 2/5 as a decimal? 0.4. Because remember, it's 4 tenths, tenths place. And then we can boink, boink, Michael, to get 0.004. How about number 32? We go boink, boink, the other direction. 2.22 as a percent. Luciana.
0.022.
Uh-oh, we're going from a decimal to a percent. Boink, boink that way, 2 places.
So 222.
222%. There we go, 222%. So number 34, boink, boink. What do we get for our answer here, Ben?
81%.
Well, that's correct for 34. It is 81%. I was asking about 33, though.
Oh. 0.25.
0.25%. Now, he's not wrong. There is another way we could write 0.25%. Luciana?
1/4%.
1/4% is another way we could write that. Look at number 37. Number 37. They want us to find 3/4% of 750. It's important to remember what the word of means, class.
Multiply.
It means to multiply. So I'm just going to multiply whatever this is by 750. But I can't multiply a percent, class. We have to change it to a decimal. Well, let's start by making 3/4 as a decimal, class. 0.75, thank you, whoever said that just now. And then, that's still 0.75%. Don't forget that. Changing it to a decimal doesn't take off the percent sign yet. The only thing that takes off the percent sign, class, is when you go
Boink,
boink,
boink.
boink. And so we haven't done that yet. We haven't boink, boinked yet. All we've done is make it a 0.75. Now we boink, boink. But we're changing a percent to a decimal. What is the decimal now, class?
0.0075.
0.0075 has to be multiplied by 750. Now, I could save myself a little work. I have an extra 0 here, class. I could knock that off in exchange for a decimal place. I could put it here. But I'm still going to basically multiply 75 by 75 and put 3 decimal places in my answer. We're running short on time, so we're not going to do it. Your correct answer would be 5.625 if you wanted to take the time to do it later. Drop down to number 38. Number 38. It says 98.4 is what percent of 820. We're on number 38. Pay attention. Well, if I'm finding a percent, we need to remember a percent is just another way to write a decimal, which is another way to write a fraction, right? So if I want a percent, I've got to make a fraction. How do I turn this into a fraction, class?
Put it over each other.
Over 820.
Remember, the first number always goes on top in a percent problem. So the 820 just goes underneath. And fraction bar tells me to do what, class? Divide. So we're going to have to divide 98.4 by 820. 1, 2, 3 digits. 1, 2, 3 digits. How many times 8 go into 9, class? Once. 1 times 820? 820. And we subtract, we get?
164.
But don't forget, if there's a decimal down here, class,
Goes up top.
but I'm not done. What do I got to do?
Add
Add a 0, bring it down. How many times 8 go into 16?
2.
Twice. 2 times nothing.
0.
2 times 2.
4.
2 times 8.
16.
Now remember, we don't leave it this way though, because it asked me to find what percent. So I can't leave 0.12. I got to go. And what do we get, class? 12%. Questions on that? Drop down to number 42. Number 42, it says 22 is 80% of what number? Do I multiply or do I divide?
Divide.
Remember, if you know both sides of, you multiply. I don't know both sides, so I'm going to divide. Here, I took the 820, stuck it underneath. Here, I'm going to take 80% and stick it underneath, except we're not going to write 80%, class. It has to be a, what's the decimal? 0.80 or just 0.8. But are you allowed to divide by a decimal?
No.
We've got to do what? Point over one place, but what you do at the bottom? Or you could think of it as 0.8 divided into 22, move it over one place here. If you do it outside the house, you got to do it inside the house. We're going to move it over, make this a 220. Make sure the decimals line up here. Now 8 goes into 22 how many times?
2.
Twice. That's only 16. Leaves us how many left over? 6. All right, bring down the 0. How many times 8 go into 60? 7. 7 times 8 is? 56. We subtract, get? 4. I'm not done yet. So let's add another 0. Bring it down. How many times 8 go into 40? 5. And now the worst is going to work out evenly. 27.5, our answer. It's been a little while since we've done some of these problems. There's a few more on this page. If you say, I was struggling a little bit with that, work the ones I skipped over. Work those and show them to me tomorrow. And I'll check them for you. I'll show them to me after school. If you're watching on video, Evie, you could always have, send them pictures. Hey, are these answers right? I could go over that with you this way. Homework for this evening is to do page 249. Page 249. Do numbers 1 through 30. Page 249 in the homework section, numbers 1 through 30, except we have not talked about 22 to 24. So skip number 22, 23, and 24. Okay, we're going to skip over those 3. Otherwise, do page 249, numbers 1 through 30. Exam tomorrow. We're going to have a review time. I think it's about 45 minutes of review. And then we'll have a quick break. Then we'll take the exam. So that's coming tomorrow. Have a wonderful rest of your day. You are dismissed.